System of linear inequalities is a lot like regular inequalities, except there are two inequalities working together. That's what a system means. A system of inequalities or a system of equations. It's two or more equations or inequalities working together. As you can see, in order to graph a system, we have to graph two different inequalities. So I'll graph the first one in purple. Y is less than or equal to negative x plus 6. Do the exact same thing you were doing yesterday. My y-intercept is 6. My slope is negative 1. Solid line. And I need less than or equal to, so I'm going to shade this bottom portion of the graph. Now I'm going to graph my second line in green. Y-intercept is 1. The slope is 1 over 2. Up 1 over 2. Dotted line. This is a greater than inequality, so I'm going to shade the greater than side of that line. Now your solution to this system is where your two shadings overlap. Do you remember when we did and inequalities and we had to have both statements being true? Here we have to have both systems both lines being true in order for this system to be true. So where we have both purple and green, that is the solution to our system. This solid line would remain solid, and the dotted line would remain dotted. My first line I will graph in red. Y is greater than negative 2x minus 1. That's going to be dotted. Y is greater than negative 2x minus 1, so greater than is going to be the top portion of the graph. Y minus 3 is less than or equal to 3 over 4x minus 2. What should I do first before I graph that? What should I do first? Jess? Very good. You need to isolate y before you graph. So we have y is less than or equal to 3 over 4x plus 1. Y-intercept is 1. Slope is 3 over 4. And this is a solid line. Less than or equal to means I'm going to shade the lower part of this graph. And the solution to my system is going to be where the graphs overlap. So the bottom right side of the graph. So technically you could erase everything else, all of your other shading, but you don't need to unless you want to, as long as you have it specifically shaded, that bottom lower right side of the graph. As long as you have that shaded and I know that that's the answer that you're looking for, that's all you need to do. You can erase if you want to, but you don't have to. Graph each system. Y plus 9 is greater than 7. Well, I'm going to subtract 9 to get y is greater than negative 2. That means a horizontal line at negative 2. If you're looking at the y-axis, think of it as a vertical number line. The y values that are greater than negative 2 are going to be on the top. And then you also need to solve for x plus 2y is less than or equal to 6. Solve for y. Y is less than or equal to negative 2x plus 3. Solid line. Less than or equal to. So the solution to this system is going to be the top left corner of the graph. And if we want to, we can make it really fun and add in. There you go. Okay. No, it would have to go up there. He's good? All right, thanks, Drew. Another inequality. So now we've got 3. We have x is greater than or equal to 0. So that means I'm going to have a vertical line at 0. Yes, Cameron. Sure. Okay, so our x values are greater than or equal to 0. Again, we have this line. Coincidentally, it's going right through the origin, but it's just cutting your x-axis in half. And if I want the x values that are greater than or equal to 0, we'll think about this like a number line. The left is going to be my negatives, the right's going to be positive. So I'm going to shade this right side to get the values that are greater than or equal to 0. Y is less than or equal to 0. That's going to give me a horizontal line at 0. That cuts the y-axis in half. The values less than or equal to 0 are on the bottom portion of the graph. What can you tell me about the answer to this system of equation? Jack? Exactly. What do we call that bottom right square? What is it, Jack?
Is it the third quadrant?
It's the fourth quadrant. Because remember, we go 1, 2, 3, and 4.
Yeah.
So even before we do the last part of it, we know that our solution's somewhere in the fourth quadrant. So for my last inequality, I'm going to subtract x from both sides. Y is greater than negative x minus 1. What'd you say? So now I have the y-intercept of negative 1 and slope of negative 1. And this is going to be a dotted line. The y values that are greater are the ones on the top. So where you have 3 colors is where you're going to need to shade, which is this little triangular part of the fourth quadrant. Shh. So that's all there is to graphing systems of linear inequalities. It's just graphing 2 inequalities at once and then seeing where their solutions overlap at. Just like we did yesterday, we are going to graph some points to determine if they are solutions to the inequalities. So what do you guys think? You guys can just shout them out to me. Negative 1, 7. Is that a solution?
No.
No, it's not in the shaded area. It's not a solution. How about negative 2, 5?
No.
No. Come on, guys. Let's make this a class effort. What about 6, 2?
Yes.
There you go, class. 0, 4.
Yes. No. Yes. It's dotted.
Exactly. It's on the line, but it's dotted. And since it's dotted, it is not a solution. This is a no. All right. How about 2, 4? Nope. How about 3, negative 2? Negative 2, 3? And 0, 4? Yes. Very good. Notice the difference between these two. Both of them are 0, 4. And one's on a solid line and one's on a dotted line. The solid line is a solution. The dotted line is not a solution. And then we just have some practice with questions. Remember, if you have multiple choice and you can eliminate something, eliminate it right away just to make it easier for yourself. What can I eliminate right away in that first one, Jess? Which one? How did you eliminate B?
Because you know that you have this vertical line that it has to be x.
Yes, it has to be an X value. So she eliminated B right away. What else can I eliminate right away? Cameron?
D.
Why can you eliminate D?
It's solid line, so it has to be greater than or less than equal to.
Very good. And now from here, we only have 2 options left. So what I'm going to do is I'm going to solve both of these. So I get x is greater than or equal to negative 1, or x is greater than or equal to 1. Well, which is our answer? Morgan? A is greater than or equal to negative 1. That's okay. So it would be C. Very good. Because we have a positive 1 here, and the part that's shaded is greater. Okay, give me something to eliminate in the second one. Yu Chen.
D,
Which one did you eliminate?
D,
Why did you eliminate D?
because it only shows an X and the Y and the X. It doesn't show the Y intercept.
Well, that's okay, because if it doesn't show the y-intercept, then we can assume that it's 0. So that could still be an option. Liz.
C, because the line is a dotted line.
Good. Now, I'm going to change B around so I have it solved for Y. So we're dealing with the same thing the whole time. So I have Y is greater than negative X, Y is less than X, or Y is greater than X. I have an idea how to do this without even graphing it. Christy? And what slope do we need? Yes. The only one with a negative slope here is A. And we know this has to be a negative slope because the line is slanting downhill. It's a negative slope. If you want to double check, Y is less than negative X. No y-intercept, that means 0. Slope is negative 1, which sure enough, that falls right on our line. Dotted line, greater than. Our answer is A.